Hello and welcome to the Oxford MAT Livestream, episode 0, sequences and series. I'm going to start with a bit of maths. Okay, so let's say you've got a sequence that's got a first term, and then after that there's some common multiplier, so that each term is the previous one multiplied by some number. So I've got my first term A, and then after that each term is the previous one multiplied by some number R, which is sometimes called the ratio, common ratio between the terms. That's called a geometric sequence. And they're really cool. They turn up in a lot of geometry problems and some number theory problems and just quite a bit of maths. There's this great fact that I'd like to tell you here at the start, which is that if that common ratio is between -1 and 1, not inclusive, strictly between -1 and 1, then the sum is sometimes called a geometric series. That sum converges, so with all of the terms, that sum converges, and it converges to this. I think that fact's amazing. It's brilliant. It's a really simple expression for that sum of infinitely many things. Hi everyone, how's it going? You alright? Good to see everyone here. Hi to Sam and Dev, anonymous person, Alice, E, another anonymous person, which is great. Welcome to the Matt Livestream. Why did I start like that? Well, we've noticed that whenever I do a project, the first video gets the most views, and the first 30 seconds gets the most views out of that video. So I thought I'd put the geometric series fact in the first 30 seconds so that everyone gets to see it. And if you're still with us, then we're going to do a lot more maths over the next hour. The theme of today is sequences and series. We've got a worksheet of maths puzzles, maths problems and puzzles related to sequences and series, based around things that are on the MAT syllabus. The MAT is this entrance test for maths at Oxford. And it's got a very short syllabus that we're going to go through with these sessions. We've got some revision material that I'd like to talk about, some warm-up problems that I've written for things that are not quite math problems that I'd like to try out with everyone here. Then we'll talk about some actual math questions, and there's some extension material as well in this worksheet that I might talk about at the end. Who knows if we've got time. This worksheet's available on the Maths website. There's a homepage for the Math Livestream down at the bottom there. And there's also, as well as a PDF version like this, there's also a web version which might be better on if you're looking at it on a phone or something. There's a web version. Or if you're using a screen reader, then the web version is probably a bit better for that. Okay. Right, okay. And yeah, questions already coming in about MAT. So somebody's asked about binary, which is not strictly on the syllabus, but there was a question about it last year. I've got a session near the end, in, goodness knows, about 8 weeks from now on, it's called primes and proof, and it contains other bits of mathematics that we think people usually know by the time of MAT. So it's other stuff going on later on in the series, the series of Matt live streams. And maybe the series will have a geometric series in the number of views it gets. Right, I'm really pleased that I got that maths in for the first 30 seconds. Good to see people back in chat as well. I recognise some of you from things like Oxford Online Maths Club, which has been in this 5 PM slot so far this year. Somebody's asked me how my day was. My day was fine, thank you. We've got thinking about A-level results day, which is coming up very soon. Good, right, okay. So I'd like to sort of get on with it, if that's all right. But I've got a kind of poll to start off with. You see that segue from we're going to get started to wait, no, I've got a poll. I'd like to start by knowing how you feel about sequences and series. In the Slido, there's a poll now, which I'd like you to rate. How do you feel about sequences and series? I guess 5 stars would be I'm really comfortable with this material. I think it's fine. 1 star would be I've never seen this before. That fact there was a surprise to me. So there's some sort of mix coming in there. This is a new Slido feature. People who have seen stuff I've done before will know that I love Slido. I haven't said it yet. We're on slido.com/matlive, MATLIVE, which is over there. Hi to Mew from Thailand. You see, I can't have this up at the same time as having the chat up. That's just a little bit bad. What A-levels did the worksheet do? The worksheet did A-level maths. The worksheets are all based on A-level mathematics or equivalent. They don't use any further maths, although I do sometimes mention further maths topics in the extension material at the end. Yeah, people are recommending learning about binary. Has Oxford Mathematics... I don't think we've ever done UCAS clearing. I don't think we've ever done it. There's questions appearing behind this poll. Look at that distribution. That's quite interesting, isn't it? Look at that. And people haven't been to one of these in a while, says someone, and now it's the summer, so here we are over the summer. Who has enough time to solve all of these problems? I know. I've put loads of problems in. I've put lots of stuff in, and I launched the worksheets a bit late, but they're all there now. All 10 of them are on the page. So if you want to get ahead, or if you've got any time at all over summer, then there's a lot more problems. Or maybe you're asking about the maths, in which case it's a long exam, and people there's a lot to do in the time. Right. Okay. MAT is held this year on the 3rd of November 2021. I'm putting that in chat just in case, it's a different day, different years. Right, okay, good chat. People have rated their knowledge of sequences and series a solid 3.9. It's pretty good. Good topic to start with. But there are some 1 and 2 star votes in there. Good 11% of people. Yeah, comments. Okay, let's switch this back to chat so that we can see all this stuff people are saying in chat. And then I do want to talk about maths. Good afternoon to Gary as well. Recursive functions. Yeah, recursive functions. We've got an entire session on recursion at the... one of the future ones is on recursion, just because it's important and interesting, and tend to be some of the question 5 sort of bit of math sometimes uses recursion. We're doing that session as an entire worksheet later on as well. And Isabella is here live. Hooray! Haven't done sequences yet. We're going to learn some sequences. Right, okay. And would I recommend watching the previous live streams from 2020? I'm going to go with no, which is strange because I'm very proud of them and I thought they were great. I'm trying to try and fit everything into these 10 sessions, and I'm going to try and keep them to 1 hour. You'll notice my schedule says I'm doing 1 hour and then a bit of chat afterwards, which might mean running over. The ones last year, there were quite a few of them, and they're about 2 hours long, and they're very rambly. They're not very tightly structured. So I'm hoping that this year's MAT live streams I can get a little bit faster. Right, okay. We're losing viewers every time I don't do some maths. So let's go. MAT syllabus then. Let's have a quick look at that together. So this says sequences. We expect you to know about sequences defined iteratively. That means iteratively, so in terms of previous terms of the sequence. So iteratively is an expression like this one. Ooh, over here. Some sort of function of the previous term. And also by formulae, formulas or formulae. So we might give you a formula like this. That's a formula. I think if you're given the choice in life, then being given a formula, it's great. It's much easier to work with being given a formula versus being given some complicated relation between the terms of the sequence. We expect you to know about arithmetic and geometric progressions. I've got some revision notes on those coming up in a second, and about their sums, so how to add together terms. There's a convergence condition in that fact that I said at the front of the session about when an infinite geometric progression, all the terms to infinity, adds up. And that's all the content that we expect on sequences and series. There are loads of other things you could say about sequences and series, but this is all that we think you know by the date of the MAT. Okay, right. So what do I want to say? There's some revision notes on this sheet. I think I'm not going to read all of them out, but hey, if you want to sort of more detail on what the MAT syllabus means, then there are notes on the worksheets on the web. There's this notation for the sum of the terms. While I was writing this out, I realised that sometimes there's this different convention going on. Sometimes a sequence might start... Sometimes we start with a naught, and sometimes we start with a 1. And if it's your sequence, if you're writing it down, then you get to decide whether you want to start counting at 1 or 0. But sometimes when you're given a sequence in a question, you might be told the first one is A0. there are advantages and disadvantages, which we'll hit on in a moment, I think. But the main advantage of starting at A1 is that A1 is then your first term, A2 is your second term, A3 is your third term. The disadvantage of starting with A0 is that that doesn't quite line up. A2 is your third term. It's out by one errors, is what the computer scientists call them, I think. Right, okay. Chat's gone really quiet at the moment we started talking about maths. It's fine. It's fine. Right, okay. So arithmetic sequence is basically one of the first sorts of sequence you might meet in life. In fact, thinking about it, the first sequence you meet in life is probably the sequence 1, 2, 3, 4, 5, 6, and that's an arithmetic sequence. It's got a first term, 1, and there's a common difference there, also plus 1. So you've seen an arithmetic sequence before. In general, the gaps can be some number d. The terms could be getting bigger, they could be getting smaller, because we can cope with d being negative, so it could be going up, could be going down. That's about it. That's about it for arithmetic sequences. So numbers getting larger, numbers getting smaller with a common difference, like taking steps on the number line. You could probably teach this to people in sort of like primary school or something, right? To have like this idea of starting somewhere and taking steps along. Anyway, the thing we teach you at A level or equivalent is this rather gnarly looking formula for the sum of the first n terms. N over 2 times 2a plus n minus 1d. Okay. I think when I did A level, that was just in the formula booklet. We're going to explore a little bit where that formula comes from and how you might remember it. The crucial thing that I think people get wrong the most is this n terms thing. It's not really like a deep maths insight thing, but again, if you started counting at 8-0, then it can be really confusing to work out how many terms you've got. Or if you started counting somewhere weird, then it can be a little bit awkward to work out how many terms have you got in this actual sum you're trying to do. Okay, I've got advice about reading this, or sort of mnemonic for how you might remember it. And we're in the warm-up problems, we've got some ways you might derive it. It's good to know where these things come from. Okay, then we've got my fact about a geometric series. So a geometric series is a different idea. I guess you could invent this if we sort of left you alone with the idea of sequences for long enough. Then you could probably invent geometric series or geometric sequence as multiplying instead of adding. That's sort of the idea, that you're multiplying to get to the next term each time. Okay, there's some other gnarly formula that you learn in A level for how to add up the first n terms of a geometric series, and again, that's the first n terms, 1, 2, 3, up to n, and there's some formula for that. I've put a way to remember that formula in the revision notes here, which I'm not going to read out now, but there's some really nice proof of how this works. If you've seen the proof that, if you've seen stuff to do with 0.9 recurring, or if you've seen 1 plus a half plus a quarter plus an eighth, then you've seen stuff like this before, I think, of this kind of thing. Ooh, hello. Ali has got an alternative formula in chat, n over 2 times a plus l, where l is the last term. Okay, so first plus last times n over 2. So that's the idea of taking the average value and multiplying by the number of terms. That works for an arithmetic sequence. Yeah, I like that. Oh, yeah, sorry, Manya's put that as well. Good, okay. Yeah, and there's something going on to do with arithmetic means and geometric means, which is fantastic maths, really great stuff. I personally love it. Not on the syllabus. I'm going to try not to talk about it today. Observation, by the way, if you're numbering things starting at 0, then that's quite convenient, because you get this nice pattern that, this is AR squared is your A2 term, and this one is AR to the 0, and this one's AR to the 1. That's all quite nice. That makes it kind of line up nicely. But remember, then your second term is A1. Annoying. Right, okay. There's reasons you might start at 0 or might start at 1. Okay. So there's this sum for the first n terms for geometric series, which it's okay if you want to treat these two as magic formulas that you learn at some point. It's probably a good idea to find out where they come from as well, but we've got these magic formulas for adding things up. Okay. The exciting thing is that for a geometric series, you can add up all of the terms, provided that they get smaller. And I mean smaller in the sense of they can change sign, because you can have geometric series like that where if r is negative, the sign alternates. You get a positive thing and then a negative thing and then a positive thing. Oh, I suppose if a is negative as well, then you get a negative thing, then a positive thing, then a negative thing, then a positive thing. The sign alternates backwards and forwards. Yes, the word converge. Thank you for calling me out on this. Someone in chat, an anonymous person, has put converge question mark. What does that mean? Which is a really good question, because the idea of convergence is kind of university maths, and it's sort of not on the mat. The idea that you're supposed to have in mind at this level is that the infinite sum, full of lots of tiny bits, getting smaller and smaller, that sum overall gets closer and closer to this number, a over 1 minus r. That if you took all of the terms somehow, then it would get really close to a over 1 minus r. So it's not important at this level for taking things like the maths admissions test to have a really solid idea of what that means. And you're not going to get asked questions about convergence for other series, which is a whole bunch of university maths I don't want to talk too much about. But this idea of approaching something, getting really close. Let me show you an example of sort of 1 plus a half plus a quarter. So this, I think the first time I met this, somebody showed me this one, of if you just work out the first few terms and add them together, then this gets really close to, well, 1 3/4 is a good starting place. If you add together all of these terms, then you get to something like 1 32 over 33. It's 31 over 32. It's getting really close to 2. That's all I need you to understand for what converging might mean at this level. So it's a really good, one word question. Converge, question mark? And yeah, it's a really good question. What does it mean to converge? People are talking about geometric means in chat, which I'm really trying not to talk about because it's something I'm interested in, but oh well. Oh yeah, and good question. If only a is negative, are all the terms negative? Yeah, sure. If a is negative and r is positive, then I think you get negative, 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 negative. Good point. Yeah, thanks for filling in that case as well. So we should watch out for that, I suppose. A geometric series where all the terms are negative, that's okay with us. So JDS says, does it converge to 0? And it's slightly tricky that the terms converge to 0. The terms get really small. The terms get smaller and smaller. The sum overall, the sum of the first n terms, converges not to 0, but you've got this. You've got all of these previous terms added up. So you're adding on a sort of smaller bit each time. Okay. Okay. So JDS. Oh no, I'm getting a bit confused. Yeah, a little bit like people are talking about asymptotes or other bits of A-level maths where you've got something getting really close to something. Yeah, sure. I'll go with that. I'm not sure. Asymptotes are quite badly behaved, and this is quite well behaved. So I'm gonna maybe not that feeling of asymptotes being badly behaved, but this just being quite nice. Anisha just reminded me of this lovely thing that you can imagine this formula. So we've got this magic formula that I haven't proved live. A times 1 minus r to the n over 1 minus r. And if you make n really big, so if r is some small number like 1/2, small between minus 1 and 1, like 1/2 in my example down below, then this r to the n gets really small when you make n really big. It's like 1/2 to the n for really big n, that's like 2 to the minus n. That's some tiny thing. Cool, good. Okay. And yeah, so what's an asymptote? So an asymptote is something that someone else was using to help understand this. If that doesn't mean anything to you, then don't worry. Cool, right. Now, Gary, you see, I mentioned geometric means too much. Somebody wants to know about geometric means. Okay. Final comment, if r is bigger than or equal to 1, then the sum to infinity doesn't converge. It doesn't get closer to any real number. It's not a sensible thing to do to try and add together all the terms if the terms are getting bigger. Right, okay. Someone's going to say people's maths is getting way more advanced than Matt in chat, which is lovely, but I need to not get distracted. Okay, cool. So I set some warm-up problems that I'd like to very quickly look at, because really I want to look at the Matt questions, but we should do some warm-up. You know, it's like going to the gym and doing exercise or something. I mean, who knows? But you've got to do like some warm-up first. Good. That's the most convincing gym analogy anybody's ever heard. Right, okay. SV's put something in chat that I haven't read. But something about taking the product of all the terms of a geometric series. Cool, right, okay. Product of first n terms, maybe. Goodness knows. Okay, right, warm up. I've got some examples of, I'm going to skip some of these for time, I think. Working out what the first few terms of a sequence are. So here I'm asking for A3 with this formula and A10 with this formula. Yeah, people want the formula. And the exercise that I wanted at the start was to find something like an plus 1 take away an, which is some calculation to do with this formula of an. I'm going to do that one on the screen because I think it's an interesting calculation. I mean, it's not an interesting answer, an interesting calculation. Okay, let's have a look. What are we doing? So if we want an plus 1, we need to do something a little bit interesting, which is to work out, you know, I've got this formula for an, what's the formula for an plus 1? Now, it can be, with a sort of iterative thing, that's a really complicated question to do with. What's the next term in terms of the previous one? But no, wait, we've been given a formula. And this formula is true for all values that we might want to plug in. Okay. In particular, what it's really telling us is this pattern to say, if you want to know what the value is when you put in 10 or something, you just replace all the n's with 10. If you want to know what an plus 1 is, you just replace all the n's with n plus 1. Yes, A3 is 6 and A10 is 90. That anonymous person. Spot on. Yeah, so someone's written n equals n plus 1, which makes me a bit nervous. I think I'm doing something a bit more like n goes to n plus 1, which sometimes makes people nervous as well. But it's worth trying this out if you're unhappy with this sort of operation of taking an and switching all the n's to n plus 1s. And then it's worth sort of checking this, maybe check this with some numbers to check that this sort of weird magic trick actually works. Good, right. Substituting in n plus 1 for, substitute n for n plus 1. Yeah, Olivia and George, I took a moment to approve your chat messages, but you're both right, that's what I'm doing. Substituting in. Good, okay. Okay, and that gives me something like, what is this then? So this is n squared plus 2n take away an n is n plus 1 take away a 1, so this is n squared plus n, which I've seen in chat as well. Brilliant. And Hannah's ahead of me. Hannah wants to subtract the an already. So if I do n squared plus n for this an plus 1, I need to subtract off an, which is n squared minus n, and I'll get 2n. Okay, brilliant. So we've worked out what 2n, we've worked out that this is 2n. The reason I did that, partly because of this slightly weird n to n plus 1 switch that I want to check people are happy with. Yeah, it's sort of like a function of n. That's a really good point, Peter. It's like a function of n. In fact, there's sort of an alternative reality where we didn't use this notation for sequences. We just used everything in terms of functions. So if you really like functions, then you can imagine this being a function of n instead. Okay, next thing on the worksheet is to work out n plus 1 minus 2an plus an minus 1 in terms of n, which is some more complicated calculation involving a new object an minus 1. Can I have any suggestions from chat of how to get going with this one? Aha, I've got an answer. That's good enough for me. Aha, George wants to take a shortcut. I'm going to call it a shortcut, not a cheat. Substituting values into the formula and in the initial formula. Check that it all works. Ooh, I've got something a bit like that on my worksheet of trying early values. People are getting 2. Yeah, people want to substitute like before. Oh, okay, I love this. So an anonymous person here. Oh no, chat's lagging for me. There we go. Final answer was 2. Somebody else says substitute like before. substitute like before it's a good idea. I like that. You can go and plug everything in. There's a better method though, which is to say that this is an plus 1 minus an. I mean, it is minus, I've got to be careful, minus more stuff. An minus 1. Okay, so I've split up the minus 2an, and I've put some minus signs outside some brackets. Yes, and somebody in chat has done that at the same time as well. Yeah, common difference of 2n. And this is a cunning idea because we can use the previous part of the question. The previous part of the question was to work out an plus 1 minus an, which is just 2n. And this next thing in here is the same thing but with n plus 1 replaced with n. What do I mean by that? So this first n plus 1 here has been replaced with n, the number before, and also this n has been replaced with the number before, n minus 1. So there's a little sort of n goes to n minus 1 substitution going on in there. So that's this. Okay, so this is the sort of previous result for the previous number. And if you do that subtraction is much easier. So you just get 2 a little bit faster. Use the previous part in 2 places, and it's cheeky. It's cheeky because I wrote the question, so I know the shortcut because I chose this combination to be sneakily the difference of the previous things. Okay, how much do I want to say about this? This is a little bit like taking the derivative because it's the difference between things, and this object here with the minus 2 in the middle, that's a little bit like the second derivative because it's the difference of some differences. I'm probably not going to get away with that in chat. Yeah, okay, okay. Might not be getting away with that. Right, cool. A little bit like differentiation. A bit. Right, okay. There are some exercises that I'm going to skip where I want you to sort of work out, practice working out, adding up the terms of arithmetic and geometric sequences. In fact, I'm going to skip most of this sheet. How long did it take you to make each question? Some of the questions took a long time to write, to come up with good examples of things, and some of them took basically no time at all. Can you guess which is which? Okay. I've got a question I like in here. Is it the ones I'm spending time on that I like? There's a question in here about given this iterative definition of a sequence, can you check that this formula works for some values of a and b? I think this is a good exercise to try. Try and work out values of a and b to make this formula work. Where overall this thing's not a geometric series and it's not an arithmetic sequence. It's just there's some rule about what you do between the terms, and some relation comes out for what the final answer is. There's a MAT question coming up that's quite a bit like this. Okay. Are these questions on the website? Yes. There is a link in the YouTube description, and there's a link. There's links everywhere. If you get to the homepage on screen, a link on screen to get to the homepage. Yeah. So these are available on the website. In fact, all 10 are available on the website. To if you want to get ahead with things, if you want to see next week's questions before the live show. Then yeah, all the worksheets are up there. Cool. Which is why I'm skipping some of them, because I figure that if I skip them and people are interested, they can do them another time at some point. Yeah, it's like discrete derivatives. Okay. Oh yeah. Okay. Trial and improvement. It took so long. Oh, is this the A and B one? Yeah. So guessing values of A and B. The trick, I suppose, is to try. If this is going to work, it's going to have to work. Have I got a 0 in here? I do have a 0 in here. A1 equals B1. It's a good trick to say, if these things are going to be equal, I'm very suspicious. I sort of really doubt that these things could be equal. Things complicated, this thing's really simple. How can they be equal? At least we would need the first terms to match up. And that gives you some simultaneous equations for A and B. And then from there, things sort of work out. Cool. Ooh. You can consider this like the equation of a line, and then there's some stuff oh my word. George has got parallels with other sorts of maths going on. Thank you, George. And somebody's put a link to the MAT Livestream page as well. Good. Right. When am I going to post the answers? I'm going to post the answers tomorrow, I think. I'll give you a chance to watch the live stream, if people are watching the live stream later, to try the questions, and then solutions going up tomorrow. A bit like if you used to watch the Maths Club earlier this year, a bit like how the further reading went up on a Friday at some point. I put the solutions up on Friday at some point. Just fits well with my schedule. Anyway, completely unrelated to math. Yeah, who knows? Who knows? I think I'll leave the completely unrelated to math stream a little bit secret now. Right. Okay. Got some simplification. I'm going to skip these. When do these converge? Or check for can you get these to converge? And then some proof questions to check that you can work out the formula. I have two different proofs of why the formula for the arithmetic sequence is what it is. You can try them out by following over here. Yeah, this is a good suggestion. Can you find Cn, guess Pn, and be left with a general equation and then solve? So I guess that's up here. Finding A, B, and C. Is that what's going on? Find Cn, guess Pn. No, I've lost track of which question that is. Sorry, anonymous person with the Cn and Pn. Okay. Right. Okay. Good. So we've got some warm-up questions. If this sort of stuff seems like the sort of thing you want to practice at a kind of A-level sort of level, then here are some questions to try. I'm particularly happy with the way these ones work. I've got a sum that I'd like you to simplify, and then I've got a trickier sum that I'd like you to simplify, where I've chosen the numbers here to be a little bit awkward for how you start counting how many terms there are, for example. Okay, right. Let's go over the first proof, and there is going to be an answer provided, but I'm interested in it. So there's this logic going around that the thing you need to remember for the arithmetic sequence. So let's go over here. Sequence. The thing you need to remember is that it's sort of the average of the first and last term times the number of terms. So there's this proof that goes like this. Take your arithmetic sequence a plus d, a plus writing, a plus 2d, and so on. A plus n minus 1d is the last term. Let's put in the previous term as well. A plus n minus 2d is the previous term. Take your geometric series, and here's what you do. Pair up the first term and the last term. Now, those add up to the first term and the last term, so that's pretty good. Now take this term and this term, the second one in and the second one from the end, pair those together, and they add up to the same thing. So if you're trying to add up all of the terms, you can pair them up, and you know what the pairs add up to. The pairs always add up to the same thing, and that's why this average of the first and last terms is important, because whenever you pair these terms together, you get twice the average of the first and the last term, because you get the same thing every time. Okay, the proof's got a slight crease in it, because depending on whether there's an odd or even number of terms, you might be left with just one term in the middle. It's not a problem for the final answer, but it is a little line in the proof that I'd like you to try and work with up here to try and work out how that proof would work. Here's the obvious question, I suppose. We're going to do some math questions now, I think. I'm going to transition to math questions because it's about past. For years I've been asked, can you suggest practice resources other than past papers? And now the top question is, can you suggest resources other than worksheets and the past papers? So there are some other recommendations on the MAT website. If you go up to /r/MAT for the MAT website, which has got the past papers on, it's got some other suggestions of other people's resources that are a bit like this one, things like the STEP support program and Enrich Mathematics, other great resources out there with other bits of problem solving and interesting mathematics. And now there's this as well. Cool. Good. Okay. Yeah, it's a proof of why George's formula, was it George? Or some people earlier told me n over 2 times a plus l. It's a proof of why that formula works, and then checking that the formula really is that. Okay. Yeah, here's a good question. I really like this one. Why is it n minus 1d and not nd? And it's the out by 1 because we started at 0 problem again. I really highlight this. Thank you for asking this, anonymous person. We're looking at the first n terms, and because we want n terms, we've got 1 term, 2 terms, 3 terms, and the pattern is when we get the nth term, this number here is n minus 1. It's really annoying that n terms means this. Quick check, if n is 2, if we're looking at 2 terms, then we definitely want these things at the front. We don't want this one for 2 terms. And then for n terms, it's like this. Let's say. Okay, and somebody's put a reply on there, which I hope is very polite and nice. Yeah, it's polite and nice. Good, right, let's keep chat polite and nice, right? Cool. People are differentiating stuff, which is exciting. Okay, right, good. Yep, good. Yeah, people want advice with enrich. Let's put enrich at the end. In the kind of just chatting bit at the end, we'll talk about enrich resources. Yeah, and George has put nice proof. Yeah, good. Okay. Maybe that's a better proof. Yes, good. Okay, good. Yeah, people are talking about out by 1 errors as well. Good. Right. Okay. Let's talk about math. So math questions are a little bit like the warm-up questions, but a bit more involved. They tend to assume that you're happy with all of the stuff that was on the math syllabus, and then ask you these kind of more complicated questions that involve knowledge using other bits and pieces. I'm going to switch on a poll for this. We're going to see how this goes. But chat's going to keep going behind the scenes. This is 2016, question 1A. I'm also going to hide results to make it more mysterious. Right, okay. Good. Let's read the question while we're thinking. So, 2016, question 1A. It's the first question on the paper. It's 2016. The first question on the paper is usually designed to be approachable, something we can just get in and have a go at. So here, sit down, open the paper, first question there. A sequence has got the first term, A1 equals 1. So it's one of those sequences where we count from 1. And the subsequent terms are defined by n plus 1 is L times AN for n bigger than or equal to 1. What's the product? Product means multiply. What's the product of the first 15 terms, that means times, of the first 15 terms of the sequence? Okay. Yeah, SV, you gave me a formula earlier about multiplying together terms of a geometric sequence. Here it is. Here's what's going on. It's only 15 of them. I don't think you should multiply together all of them. I'm a bit worried about that. But here, yeah, we're just going to multiply together 15 of them. People having a good go at this? Yeah, people having a go at this. Yeah, okay, good. So, I'm a bit annoyed. This time symbol has come out looking like a big sort of angry cross. I'm going to maybe turn this into some maths. So I want, I suppose, A1 times A2 times A3 times ... times A15, where I'm really concentrating to get 15 terms here, because this time it starts at A1. So 1, 2, 3. Good, right, the third term is A3, so the 15th term is A15. Phew, okay. What is the 15th term? It's a new question. I suppose what's the first term and the second term? What are all these? Is this about... I don't know. Someone says they may have done an out by 1 error. So checking that you've got... This is a little bit forgiving, I suppose, for out by 1 errors, because if you forget to multiply by the first term, you're okay, because that's multiplying by 1. That is a forgiving thing that this question does. Yeah, Olivia wants to look at the exponent of this. A great idea. Good. Is there no convention? Yes, I think there's not a convention about whether they start from 0 or 1. This first one here starts from 1. This one starts from 0. Those were on the same paper. So I think I'm going to say no convention. We'll start with 0 or we'll start with 1. We'll make it clear in the question which one we're doing. Maybe it wasn't a great idea to have both going on in 2016, but hey, here we are. Right, L to the 14 is the 15th term. Yeah, okay, so that's a good point. What do I mean? A15 here, the 15th term, is L to the 14, someone says in chat, which is pretty good. JDS is going to be disappointed by that, so you've just put in chat, I think you might have out by 1 errored, maybe. I think it's L to the 14. because the first one is sneakily L to the 0, and then A2 is L to the 1, A3 is L squared, and so on. Okay. But having this, yeah, it's confusing that the 15th term is L14. We were just so happy that it started at 1, and now this feels like maybe the sort of one where we should have started the subscripts at 0. Oh well. E has got, the user with the username E has got the suggestion that maybe you can cheat at this one by trying out different numbers. I'd love to know what numbers to plug in. Will this page that I'm writing on be available? That's a nice idea. Sure, maybe I'll export. Yeah, okay. That's a nice idea. Why not? I'll export the image and stick it on the website. Good. Never mind. Yep, JDS is with us. AN is L to the n-1. Cool. Right. Okay. So we want to multiply all these together. Olivia had a suggestion that we could think about this in terms. I've been cheeky and missed out the L to the 0. L to the 14 is, we could think about that in terms of exponents. We want all of this. So we're going to need to actually add some numbers together, not multiply some things together. I think that's brilliant. This turns out to be L to the 105, which is option D. Let's have a quick look. How did chat do? Chat did pretty well. Look at that, 90%. Ah, brilliant. On 81 votes as well. Good stuff, chat. Chat's picked that. Other popular answers, people picked A and C a little bit as well. I can sort of see A and C. I can see A as a, yeah, that is one of the terms, I suppose. And also, if you're if you work them out by, yeah, amazing. And C has got this L to the 14 in as well. Okay, good. Right. Okay. Debrief. Good. Okay. Back to chat. So were people sneakily checking? So I like it when people try and eliminate options in multiple choice questions by checking what happens for special numbers. So if L equals 0, then this is the sequence 1, 0, 0, 0 forever. So the product of the first 15 would be 0. That's exciting because it rules out B and E, both of which are not 0 when you plug in L equals 0. I think if you then plug in L equals 1, then your sequence, because then you know your sequence is 1, 1, 1, 1. I think that rules out C. So then you're down to A and D. So we're sort of doing the question without doing any mathematics. I think this is what E was suggesting earlier on. Right, good. Okay. If you squinted it, it looks like an italic 1. So yeah, if you replace all the L's with 1s, then you get useful information about the question. That's quite nice, isn't it? If your handwriting messes that up, then you can be all right. Yeah, something about triangle numbers. Questions about MAT as well. So about 5,000 people take the MAT. Are MAT questions designed to trick you into picking a wrong answer? No. We're not trying to trick you. We want the wrong options to be plausible, so that it's not correct answer and 4 nonsense answers that are obviously wrong. But we're not trying to trick you with the wrong answers. Okay. Yeah, and this question it's not supposed to be a trap. I suppose if you're on autopilot and you add together the terms of a geometric series, then I mean you don't get any of the options, so you don't answer the question like that. But you know, we're asking something that's not quite the standard thing. Maybe that's different. Okay, it's getting very dark. It's a sign I need to speed up. Right, cool. You get your results. You get your results through an automatic email if you've applied to Oxford. Why is there a 15 plus L to 105? I don't know. Nobody picked it today. Right, cool. Next question. We've got a new sequence. It's defined by first term 1, which is x0, and then each term after that is the sum of all the previous terms. So, for example, I suppose x1 is going to be the sum. So this notation means the sum, so it adds together everything from when k equals 0 all the way up to k equals n-1. So in general, this means something like x0 plus x1 plus x2 plus ... plus x n-1. You take k to be each of those numbers, and you plug them in and add all the things together. But to start off with, when n is small, like the number 1, this just says stop. Stop the sum immediately. Take x0 and then stop. Okay, that's the number 1. x2 is something like x0 plus x1, and then stop, because we stop at n minus 1. So that's 1 plus 1. 1 plus 1 is 2. Welcome to the Oxford MAT Livestream. 1 plus 1 is 2. And then I think x3 turns out to be x0 plus x1 plus x2, and then stop. So that's 1 plus 1 plus 2. That's 4. Now my spidey senses are tingling. Oh, Gary says Fibonacci, because it looks like adding together previous things. This does look a bit Fibonacci over here. Fibonacci. But down here, this looks less Fibonacci. In particular, the number 4. Not Fibonacci. Right. Okay. x4 is x0 plus x1 plus x2 plus x3, which is 8, I think. 1, 1, 2, 4, 8. Yes. And now I'm getting really suspicious. I haven't read on yet. So the thing we're actually asked for is the sum of the reciprocals of xk from k is 0 all the way up to infinity. Add together all of them, which I don't want to tackle yet until I've worked out some small values of x, xk, some small numbers to plug in. Once I've done that, I can start thinking about this sum. Oh no, it's okay. So somebody says they went to 32 and then noticed what was going on. That's fine. Oh, by the way, 32 is one of them. Yeah, it's not Fibonacci. It does grow exponentially, like the Fibonacci sequence does, but it's just the powers of 2, isn't it? So x2 is 2 to the 1, 4 is 2 squared, this is 2 cubed. So this sum here is going to be 1 over x0 plus 1 over x1 plus 1 over x2 plus 1 over x3 plus 1 over x4 plus, and so on. And now what was looking like a really scary thing involving sums of things that are themselves sums, and you could write down some horrible sum inside a sum notation. What was going to be a really horrible thing is now actually quite a nice thing. 1, 1, yeah, okay. 1, 1 plus geometric series. Cool. It's in fact 1 plus geometric series if you're really ambitious. Someone's called that a telescopic sum, which is interesting. Yeah, I think it's a geometric series, isn't it? Yeah, and the suggestion, okay, right, so I think this adds up to something nice, because I've got all of these fractions half of each time. That's geometric series. It's the a over 1 minus r fact from the syllabus. I think this turns out to be 3. And that is also what chat thinks. Even more so than last time. It was 98% on that one. Good job, chat. Here's a really good question. So people are suggesting that we should maybe have put in 2, option F2 as a kind of trick answer, but we're not doing tricks. We're not trying to trick you. Yeah, missing out the first term or forgetting that there's 2 1s at the start or something. Nah, not doing that. Question about how long these are supposed to take. I suppose the technical answer is something like 6 minutes. Because if you divide the number of marks on MAT by the amount of time you've got, you can do this estimate of how long you've got for each mark. Works out as about 6 minutes, I think. But some of them are easier than others. So actually, when you're doing them, it's maybe not very helpful to think 6 minutes, time's up, I'm moving on. Goodness knows. I feel like yeah, I feel like I don't really think like that in terms of doing my maths. Like, I've got to do it in 6-minute blocks. I sort of do maths questions, and some of them I can do faster than others. And about an hour into the test, I might think, oh, I'm an hour in. Have I had a go at question 1? I might look at the other questions. It's really good, isn't it? It's strange that it's strange that the first one is so x0 is 1, and then x1, let's be really careful, x1 is the sum, so n is 1, is the sum from k equals 0 of xk up to 0, because n minus 1 is 0. So that's just the sum. This sum over here says add up all the terms starting from x0 and going as far as x0. So it's just this. Oh, so this is just do this sum with just one term in. Okay, it's just equal to x0. x0 happens to be the number 1, so x1 is also 1. Does this converge? Yeah, this converges. It's a good thing it converges, because if it didn't converge, then none of these would be the right answer. A good thing it converges. Right, cool. People are already having a go at question 1c, which is very exciting. Yeah, okay. Don't look at chat if you don't want a spoiler on question 1c. I've realised I shouldn't maybe have put those chat messages through, because now they're on screen. But hey, let's talk about question 1c. Question 1c is just different. It doesn't involve any geometric series or any arithmetic series. You're just presented with a sequence. It's got this quite complicated property. I like to think of these in words. This says that for every n bigger than or equal to 2, who knows, but this says that each term, maybe not the first one, because this is not going to make sense for the first one, or maybe the first two. Each term is previous term divided by 1 before. And now that I've written it out, now that I've written it on the screen, I can see that I've just replaced the things with words in the same shape, including equals has turned into the word is. So this is not an efficient notation. But this is genuinely what I think in my head when I read something like this. Say, okay, an plus 1, that means an, oh, that's the previous term, and it's been divided by, the one before that. Okay, now I have to get some sort of understanding like that in words so that I can go work some terms out, which is what I want to do. Okay. These questions do have nice solutions so far. Yeah, it's been, what has it been so far? Let's just quick scroll up. D has been a nice compact formula over here. And then we have our solution D equal to 3, which you wouldn't have guessed from this kind of double sum setup. This one turns out to be nice as well. Yes, sorry. Yes. Ooh. Peter, I disagree with one of your xm minus 1s. I think there should only be 1 there, because that term only appears once. X0 is equal to xm minus 1, but that term's only in there once. Okay, right. Sorry. Did we put a UKMT? Oh yeah, we put the question number in the question. That's a bit UKMT, isn't it? UKMT maths. UKMT is United Kingdom Maths Trust, and some of their questions have got the year number in. I tried to put the year number in a question recently, and we decided that it was better to not use the year number for that particular question. We used a different large number instead. Okay. So yeah, this is 2017. So people who've been working out terms in the sequence, I'm not even going to do a poll for this one. People who've been working out terms in the sequence have found something interesting. You have to get out to A7, I think. So A1 is 2, A2 is 6, A7 is equal to 2, and A8 is equal to 6. Yeah, there's some terms in between. I don't just know that by staring at it. I had to go and work out the terms in between. But once you've got round to there, 2, 6, after that, you start doing exactly the same calculations again, because this equation that I've turned into words only uses the previous two terms. So if you get some repeats like this, if you get the same two terms again, it starts repeating again. So it goes around again. Yeah, people are calling this periodic or something. Like it's got some period. It's an idea from physics, I suppose. This thing goes round and round again. So actually, whilst looking really scary, like it might be a sort of continued fraction, kind of nested mess of things, in fact, if you experiment with it, then it turns out that the numbers just sort of repeat through there. I quite like this because it looks really hard, but then if you're rewarded for trying out some terms, for putting things together. Okay, good. And it turns out, oh yeah, Josh found the answer. The answer is D again. It's 2. How do you work out the next term? Sure. Okay, so when I look at this, if I want A3, so I'm thinking maybe put in n equals 2. If I want A3, then I can put in n equals 2, and I'll get A3 is A2 divided by A3 minus 1. 2 minus 1 is 1. I'll be really careful here. I want A3, so I'm putting in n equals 2, and then I get this expression. A3 is A2 divided by A1. I know A2 and A1, that's 6 divided by 2, so that's 3. And then I'll keep going. I'll try different values of n, and actually the shape of the formula is always this. It's always previous term divided by 1 before. Okay. Is modular arithmetic here? No, there's no modular arithmetic on the maths syllabus, and we don't expect people to know it by the time of the test. So some people in chat were just talking about mod for something to do with 2017 being 1 more than a multiple of 6, but in terms of finding out where 2017 is in this pattern, it's just, it repeats every 6, so subtract off some 6s. Oh, that's the same thing as dividing by 6 and finding the remainder. Yeah, I guess we expect you to do the remainder. Yeah, Matthew's got a great follow-up question, not here, but Matthew's follow-up question is this periodic for specific numbers, A1 and A2, or is this always the case? Great question, Matthew. Really brilliant. You should try it out with a general A and B at the start. That could be a warm-up question, to be honest. Yeah, I've got it in my notebook because something I wanted to try. Okay, good. Right. We got a long question and we got basically no time because we've been having so much fun with the short questions. So I want to walk through what the steps of the question are. I think we might not tackle this one all the way through live. I'm so keen to get it into an hour. Let's do a bit of it though. This is a longer question. Matt has these short questions at the front. Everyone does these 10 multiple choice questions at the front. And then you do 4 longer questions. Depending on which course you've applied for at Oxford, it's complicated. There are rules on the front of the paper and on the website if you want to find out which questions you're doing. But everyone's going to do question 5. That's one of the ones that everyone does. So question 5 is for everyone. Okay. The longer questions are worth more marks, and they're marked by our graduate students who look at your working out. You might be asked to prove something or show that something. Let's have a look down here. Show that. Ooh, I've sort of missed with that box. Right, cool. Regret that. Okay. And sometimes you're given some new maths or given some new information. So here we're given a new sequence. And it's not a geometric series and it's not an arithmetic series. It's some things added together. And we're asked to do things with it. So this can be quite scary because we've been presented with some new maths that isn't the thing we know from the syllabus. But the things we're asked to do with it are actually quite reasonable. The things we're going to do with it use the maths that we know. They use the kind of algebra that we're familiar with. So here, this kind of thing we've been doing about setting small values of n and looking at the first few terms of the equation. In the warm-up, we had that one about looking at the first couple of values to try and solve for a and b. Here, the question, all it wants us to do is to set n to be 1, 2, and 3 to work out for the first few terms of this series. Can you match up the values Sn? Can you match them to values of this crazy function? So this is the function f of n. It's a function an plus b times 2 to the n plus 6. Crazy idea. Who knows where that comes from? Can you match these things together? So that looks really impossible because of all the different letters of the alphabet around. But when you actually plug in the numbers 1, 2, and 3, if you want these things to be equal for 1, 2, and 3, you get equations out. You get lovely linear simultaneous equations. So that's really nice. Yeah, people are reading on as well. And then you go and solve the equations, which is something you can do because now you're just solving equations. You're working with some simultaneous linear equations. Simultaneous. Aha. We've got a session on algebra coming up later. Let's put this here. Let's put a heart because we love solving simultaneous linear equations. There's a part 3 here to say, okay, you've made that work for n is 1, 2, and 3. Check that. If it's true for sk, so if sk is equal to f of k, then something about sk plus 1, or an extra step. That involves thinking about what the difference is, what changes when you go from sk to sk plus 1. I mean, in some sense, you replace all the k's with k plus 1s, but what does that actually mean for the sum? The sum still starts 2 plus 8 plus 24, but if you go to k plus 1, then that means there's an extra term on the end. So thinking carefully about this fact about sk that you know, that sk is this sum and it stops at some point. And then sk plus 1 means I take an extra term in the sum. comparing that together gives you a way to, using that information about how SK changes, gives you a way to say, I can see how this compares. It is sneakily proof by induction, but without needing to know anything about proof by inductions. Can we use matrices? Yes, you can use matrices if you like. We don't expect you to know about matrices, but if that's how you want to solve your simultaneous linear equations, then go for it. The graduate students know about matrices. Good, and people are doing a little bit of chat, which I'd like. Maybe we're going to do some chat. Oh, does UN converge? Oh, for large n, does UN converge? Great question. It's a bit like 1/2 plus 2/4 plus 3/8. I think it converges, or it definitely converges to something. I should have looked this up. Yeah, I think it converges to maybe 2, or something like that. Cool, right, good. Okay, so that's the structure of the question. We're going to mess around with some linear equations and find this formula, f of n, some equations, some nice equation for what this sum sk is, sum Sn, what that is. Second half of the question is, we're now going to assume that we know that formula, that's worked, that's done now. And we're given some new things, we're given some twists. Can you do these sums instead? Can you use that information you've just worked out? Amazing. You came into this question, you didn't know what this sum is, don't know a formula for it. Now, by merely halfway through the question later, we do know a formula for that sum. Brilliant. Can you use that to do stuff? So now this is in your kind of armory. It's another weapon you know how to do sums like this. What does sums like this mean? Can you do a sum like this? Can you do a sum like this? Finding out how these things are related to each other and how they're related to Sn is a good idea. Okay, the last part of the question is to add together the terms of SK. Sorry. At this point, you know the formula for SK, so this is not as bad as it looks. Imagine back to that double sum short question we did with the 2 different sums in, where we got our heads around the first one first, then we had a nice formula, it's just powers of 2, and then we thought about the second sum. Here, this is sort of similar idea, right? We've got this first sum, and then we're going to get our heads around that, we're going to get a nice formula for that, and then think about adding together the terms of this. Okay, so people are now asking really good questions about MAT that I'd like to try and address. So I think I'm going to stop talking about the MAT questions now. They're on the worksheet. The worksheet's on the web. If you want to download them and have a go at them, then they're there. Also, big bank of hints for that longer question on the page as well. And the solutions I'm going to post tomorrow, but I'd like to chat to people a little bit about some good questions that have come in about MAT, if that's all right. So if you've got to go, then bye. I'll see you next week for whatever next week's topic is. I think it's either geometry or trigonometry, I can't remember. It's one of them, for some more MAT questions. I'll try and go a little bit faster next week so that we can spend more time on long questions. And if you're hanging around, let's talk about MAT. So somebody's asked about what a good score is on the MAT, including how many questions for multiple choice should we aim to get right. A good score is about 70%. 70% is pretty good for MAT. That would mean getting 7 out of 10 of the short questions, the multiple choice short questions right, about 70%. More the better, really. The more marks you get, the more likely Oxford is to shortlist you for interview. As we use the MAT early on to decide who we're going to shortlist, together with other information that we know about candidates. The Venkata asks about the mark distribution, which is, so there are 10 short questions. So 10 short questions, 10 times 4 marks for the short questions, and then 4 times 15 marks. So those are short questions. Those are long questions. That adds up to 100 marks, if I've got it right. Okay, good. And we don't show the number of marks for each part in the long question. Somebody earlier asked, is there a way to deduce it or to work it out? And E wants to know why we don't do that. I'll do the second question first. So we don't tell you which bits. We don't want to tell you which bits are harder than other bits. We don't want to say question that looks really difficult, brackets 1 mark, because then you will try and look for a cheat or you'll try and look for a trick without kind of thinking of that naturally for yourself. In real life, when you're faced with problems, you don't get the kind of difficulty rating in brackets afterwards. So we're trying to mirror that a little bit. We don't tell our students on their exams. We don't tell our students how many marks there are for each part. So there's that. You can kind of work it out a little bit by how hard you find the parts of the questions. If the question is quite hard, if you've had to do lots of work, there's probably worth more marks. Because we give marks for working out. Somebody asked about this. We give marks for working out. We look at what you're doing. If what you're doing is a method that would work towards the solution, then we can give you marks for working out, even if you don't get to the final answer. We usually have a couple of ways of doing the question in mind. We've thought of a couple of ways to do the question. But sometimes people come up with new ways to do the question, which is exciting, and you get marks for doing it in a new way. It's very exciting. We have to work out how many marks to give you because we've got to work out how far you are through this exciting new method that you've come up with. So that's a thing. That's on the long questions, like question 5. I think we could start showing the number of marks on each part of the long questions, and it wouldn't be that weird. It'd be a little bit odd that this would be labelled as like 3 marks or whatever it is. And you would think, looks hard, but it's probably easier. Do I need to tell you that? I don't know. Okay. Chit chat time. Is there error carried forwards? Somebody asks. And yes, a little bit. If you make a mistake and it just affects the rest of the calculation, then you lose accuracy marks, but you can still get method marks for having the right ideas, for engaging with the question and having good ideas about how to make progress. If you make an error that makes the question really easy, then sorry, that's not the same thing. Right. Okay. Somebody asks, should we use the hints for the questions, or is it a good idea to try and do it longer without? Should we try and do it for longer without? So the hints are there if you want them. I've tried to leave as much gap as I can between the questions and the hints. If you want to look at them, that's fine. There'll be a chance towards the end of this live stream session thing, in about 10 weeks from now, we're going to look at some past paper questions without any hints. We're just going to look at sort of a year of questions. The hints are there to help you if you want them. If you don't want to look at them, then either cover them up or get a copy of the question without the hints. So if you go to the MAT past papers website and look up the questions, then the original question paper didn't have the hints. So if you really don't want to see the hints in blue, okay. You can look at them if you like. Sometimes they've got good ideas in. Not all of the ideas are good ideas. They've also got some bad ideas in sometimes. But bad ideas that make you think about the question. So good ideas in that sense. It's trigonometry next week, is it? Okay, good. Question mark topics. I'm going to take Hannah's question. I've been trying to look into more high-level mathematics because there's so much I have no idea where to start. Do I have any advice on not being overwhelmed? So looking into high-level mathematics, great, sounds fun. We've been running something called the Oxford Online Maths Club, which has tried to look at higher mathematics, to look at more advanced, interesting things, but in quite a casual way. That was from January. We've been doing that as a weekly show up until July. So January to July, we've got some episodes out there on the Oxford Online Maths Club website. Looking at higher maths topics, just picking different topics and talking about them, usually with current undergraduate students. So I think it's been quite a friendly introduction. There are lots of other good YouTube channels out there, of course, as well, looking at other bits and pieces of mathematics. There is a lot of mathematics. It's one of my favourite things about maths, that there's loads of it. There's loads of stuff out there. I really like. There's loads of different things to find out. It can be overwhelming because there's so much of it. I think it's okay to not enjoy all of it, to say some of it, well, it seems very confusing and weird, I'm going to ignore that bit and focus on something else that I'm interested in, or something that seems nice, I'm going to try and find out more about that. That's okay, that's allowed. Cool. Question, how much should I get in math? More the better, I think. About 70 is a good score, more than 70 is pretty good. Please try and score points in maths. Even if I mess up for my personal statement, they say. So I don't really know how you could mess up your personal statement for mathematics. Your personal statement would have to be really bad. It would have to be like, I hate mathematics, don't shortlist me. It would have to say that for that to be the reason why you weren't shortlisted, I think. I'm joking a bit, but yeah, your personal statement, if you did well on the MAT, your personal statement was a normal personal statement. I'm way more interested in MAT scores. Has the time for MAT been confirmed yet? It's usually 9 o'clock in the morning if you take it in the UK. It's the same day as a different exam. Make sure times don't clash. Usually 9 a.m. There's advice out there on what happens if you've got exam clashes, and if you're taking it at school or college, they can probably help. Am I involved in computer science questions? Not very much. So computer science department writes questions 5, 6 and 7. We work together, so they give me feedback on my questions from maths, I give them feedback on computer science questions. We work together, but they write them. 7 out of 10 on your first paper, anonymous person. 7 out of 10 is pretty good. Yeah, 70%. Yeah, no, that's pretty good. Have a look back at all of them, and see if you can learn anything about which ones you got right. If there's a pattern, I don't know. In some sense, there's loads more questions, so you could just do more questions. But sometimes looking back at questions is good as well. Enrich was the thing I was going to do. I think I'm doing well. Error code 4 is in there. Prove Riemann's hypothesis, 2 marks. You see, if you say prove Riemann's hypothesis, 2 marks, people get suspicious. They're like, that guy knows how to prove Riemann's hypothesis, and it's easy. It's sort of a big clue, right? maybe that'd be a good way to prompt people into doing that. Okay, let's go on the internet. What could possibly go wrong? Right, okay, I've got Enrich over here. So this is enrich.maths.org. And I said we would have a look around at what's on Enrich. So I'm also going to catch up with chat. Ross, if it's a numerical answer, not a proof, you should get marks for the correct answer. Usually they say justify your answer, or show that, or prove. Usually there's text to say justify. It's good practice to put reasoning to show you're working out. In fact, I think the instructions on the front of the page say, please show you're working out on MAT questions. If you get the answer right, do you get so same question, do you get the marks regardless of your working out? If it's a question that asks you to prove something, then it's definitely about the working out. Sometimes it just says write down the answer, so you can write down the answer to get the marks. Should I go chronologically? You can do whichever you like. You can and an important question, you can do the long questions first if you want to. There's no order to the sections. Is there a pass mark? Is a really good question. No, we look at other factors as well. So if somebody's got a lower MAT score, but there's other reasons why we think they're really interesting and we'd like to shortlist them for interview, really good at mathematics, other evidence, then we might be more likely to shortlist them. Usually though, more score the better in MAT, but no hard cutoff. Whatever this is, do you do different marks for different parts for different people? No, there is a number of marks for each part of the question. We don't print it on the page, but it does exist. That is a thing. Okay. Rule of thumb on how much detail. Please use some words. Sorry, chat's full of really good questions now. Same level of detail. The solutions on the MAT website are a little bit weird sometimes. I usually encourage people to just put any words at all. Do your maths, that's fine, but then add in if, then, so, therefore, so, I'm done. And if you just add in a few words around the structure of what you're doing, that's usually enough. He says cautiously. Fibonacci user. There's a little bit of overlap between the worksheets and the ones from last year. I'd say about somewhere below 10% overlap in questions. So sometimes you'll recognise a question because I used it last year. That's in the warm-up problems. Thinking about their warm-up problems from last year. The MAT questions overlap about 20% to 30%, I think. There's some of the same MAT questions again. How often we see good ideas crop up in question answers that have never been seen before? Happens a couple of times a year. Sometimes it's something really obvious that we just haven't thought of, that loads of people have done. and sometimes it's a genuinely different approach, which is amazing. Oh yeah, sometimes there's hints in square brackets on the maths exam. If you use the hint, do we get marks? Or is it obvious? So you might get marks for using the hint. You might get marks for, if the hint says, hint, try n equals 1, and then you try equals n equals 1. It's good stuff. You might get a mark for trying n equals 1. Yeah, that's all right. Something that predicted grades. Oh, Ali recommends the further reading from this. Right, okay, enrich. We're going to look at enrich together. Okay, what have we got? We've got post 16. That sounds like us, right? And post 16 up here. I'm going to click on that. I don't really believe too much in the age ranges on it, enrich. Sometimes there's really good resources that are marked sort of 7 to 11. Right, how to get your solution featured. Right, well, there's stuff going on in over here. I'm going to go down. So step support program I talk about a lot. Let's try thinking mathematically and see what's going on over here. Okay, right. So we've got some skills that you need to be a mathematician, I suppose. I'm going to go thinking strategically. Okay, right, so we started at post 16 and we've got the 7 to 14 year olds in here as well. I quite like these, so let's have a look at dicey operations. So this has got a challenge level of 1 star and age 11 to 14, but hopefully we can try and put on our own spin on this as well. Oh, this is a game to play with 2 people. Oh, right, okay. And it's to do, so there's some instructions for 11 to 14 year olds about throwing dice and putting in cells. I reckon I can play this. Oh, right, now subtraction as well. Okay, I really like these kind of games because they're set for younger children to play as a game. But if you think about them a little bit, you can find these kind of probability questions or ideas about strategy or ideas about what's likely to happen. You can sort of outthink the 11 to 14 year olds here. So what's the optimal thing? If you roll a 5 on the first roll, should you put it in the middle? Should you put it down one of the sides? You're trying to add up to 1,000. Can you find some sort of strategy? Here maybe you're trying to think of strategies that the 11 to 14 year olds won't think of. Let's try and find a harder one. Product Sudoku. Crossing the bridge. Oh, I love this puzzle. This puzzle's really good. And it's got an interactive. Oh, that's loading. Okay. Recommendations for maths YouTube. I like Numberphile. I'm going to shout out Numberphile. There we go. They don't need a shout out from me. Oh my word. We're crossing a bridge. And there's rules about how long it takes people to cross a bridge. Oh wow, look, okay. Choose this one and this one. Yeah, and then they cross the bridge. Oh, okay, I love this puzzle. This is a really good puzzle. I haven't scrolled up to show you the puzzle. But the way I use enrich is a bit like this, to sort of have a look around the problems, ignoring the age ranges, and sometimes trying to make up my own sort of twists on the problems. Okay. How to stay up to date with maths news or the maths community. There's a really good magazine that I've only just found out about that maybe everyone already knows about, but it's just amazing. I think it's really good. So it's this one. It's called Quanta Magazine, Quanta magazine. I think it's really good. It's got mathematics news and information, and it's really well written. If you want to stay up to date with what's going on in maths, decades old classification problems, it's sort of well written that you'll understand something about what's going on. Galois groups, proof assistance, rational points like your job depends on it. I think the articles are really nice in Quanta Magazine. Yeah, cool. Good, right, okay. It's an experimental new bit of the live stream where I show you websites. Okay, right. Something else to do. Differentiated. Good personal statement. Yeah, enrich again. Sorry, somebody asked for enrich quite a lot of times in chat, and it's taken me a while. I'm a little bit behind with chat. I'm like 8 minutes behind with chat. Yeah, okay. So if you don't do further maths, I'd strongly recommend picking up further maths AS level in year 13 if you can. If your school or college will let you do any further maths at all, then further maths will be a way for you to see complex numbers, which you'll really like. You'll just really like complex numbers. They're great, and the rest of further maths is cool too. If you don't do further maths because it's not offered in your school, then the standard offer is A star in maths, AA, and 2 more subjects. That's the standard Oxford offer for people who are at schools that just can't do further maths. If you chose not to do further maths, then I'd really encourage you to pick up some further maths. so that you can see more further maths. Okay, curve sketching ability. I sketch lots of curves. We've got some coming up in graphs and transformations, which is episode, I can't remember which one, in a few weeks' time. I think it boils down to looking at key items of curve sketching, bringing them together. Oh, right. Una, do you reckon starting with old papers or new papers? I would start with old-ish papers. So I've gone back to 2013 for this live stream. Not today, but going back to 2013. And I'm saving the most recent view as past papers to try near the end before we sit the actual MAT in November. If you go too far back, the questions get a little bit different in how they work. Maybe easier, maybe harder. It's a bit hard to tell. And very recent ones you might want to save as past papers to do for the test. Okay. There's no part marking for the multiple choice question. Who makes the MAT questions? I do. No, that's not true. There's a team of people who come up with MAT questions. I'm on the team of coming up with MAT questions, so that's fun. Other evidence, yeah. So people are calling me out on saying something like other evidence, not just the MAT. We also look at your predicted grades. Somebody asked about if my predicted grades are not very good, but my MAT score's great. Well, that's an interesting balance. We look at your predicted grades. We look at your previous exam grades if you've got some. We do look at the context of your application. Somebody here says, my home country has weaker maths curriculum than the UK. So there's some sort of contextual information that we might know some context around your application that might give us more information. So that could be interesting alongside your MAT score. Obviously, we'd like it if everyone did really well in the MAT, but we know that there's other factors going on. So we don't just shortlist on the MAT. We've got the rest of your UCAS application to look at. Yeah. Okay, sorry. So chat's not being very dynamic because I'm getting behind with chat. Right, I have to approve chat messages. Yep. Okay. So Josh wants to know about math and philosophy, which also uses MAT and is also looking for a high standard of mathematician because math and philosophy, you've got to do a lot of maths on that course, including some really hard logic and set theory. So that course uses the MAT as well. Those people are also good at philosophy. I think in the past their average MAT score has been it's been harder to calculate because there's fewer of them. But there's a little bit more context going on there, right? That you need people who are good at philosophy or interested in philosophy as well for the maths and philosophy course. So maybe more varied MAT scores a little bit. I think looking at the variance is also hard because it's fewer people. If your school doesn't offer further maths, then you can still apply for maths. Standard offer A star AA, A star in maths, A in 2 other subjects. More information on the maths department webpage under our offer. Good, okay. Somebody wants to know what I got in the maths, which is awkward because I didn't do the maths, because I didn't go to Oxford. Right. George would like a live stream on logic and computer science. The closest I've got is a stream on recursion, where I've got a computer science person coming on as well to talk about recursion and that sort of style of question. Lots of the computer science questions don't really use any of the maths from the syllabus. They're just testing how you deal with being given some basic bits and pieces and putting them together. But I'm going to do that. Yeah, error carried forwards again. So continued errors. If you make the same mistake lots of times, that's bad. If you make one mistake, then you should still be able to get marks for your working out later on. Quite often the questions don't do. Quite often we don't need to do that because the question has told you a fact, and then you're using the fact. So there's these kind of checkpoints midway through the question to check that you're not going too far off the beaten track, going too far lost. Can I give you an example of a good and new approach? Different test, but good and new approach. Yeah, so usually it's people who know extra bits of mathematics. I think the best summary I can give you now, that sometimes people know extra bits of mathematics and they're keen to use them, and miraculously the extra bit of mathematics is also useful for doing the question, and it might be quite a niche bit of mathematics. So that's happened sometimes, that some people know this extra niche bit of mathematics that they get to use on the question, but often that's not the normal experience of doing math questions. Normally, everyone's using the same maths. There is not part marking on the multiple choice questions. Multiple choice questions, you either get right or wrong. Let's put this up here with this bit. Yes or no, 0 or 4. And this has got part marking. Okay. What is the step support program? Do you want to know about the step support program? Yeah, let's go and look at the step support program. Sounds fun, doesn't it? The step support program is a bit like this. So the step support program has got these foundation modules, in particular. Well, it's got different modules. It's got assignments. The assignments work like having a warm-up problem, some preparation, and then some step questions. STEP is this exam, a maths test that Cambridge used for admissions. This has existed for a while. It's got some nice warm-ups and some nice step questions. It's been out there for a while. It's a really good resource on different topics, with some extension material at the end. It's the program that's most similar to what we're doing now, but from Cambridge instead. For years, people have been asking me for a MAT support program, and this is the closest we've got so far. A series of worksheets with some extension problems and warm-up problems. Okay, is STEP useful? Yes, I think that could be useful as well. People are there. Have I ever been on Numberphile? No, I'm not famous. Hashtag get James on Numberphile. Would I like to be on Numberphile? Yeah, would be brilliant. Love Numberphile. How do we mark our own papers for the last 15 mock questions? Oh, you don't mark your own papers. I mark your papers. I get my army of graduate students to mark your papers. Don't worry about it. If you're thinking about past papers for practice, there are solutions on the MAT website. There are these solutions from the MAT website. If your solution is roughly correct and looks like the web solution, I'd give yourself the points on your practice paper. You deserve it. If you got about halfway, then about half the marks. I think that's the best way to, if you're marking your own things for practice, then be honest to yourself. How far through the question do you think you got? There are fake proofs in there. Yeah, so Quanta, I'm so behind on chat, sorry. Right, okay, let's try and focus on catching up with chat very quickly. Quanta's brilliant. It's written not just at your level, it's written at my level, it's just really well written to the point where whatever level you're at, you can get in and understand some research level, cutting edge maths that's happened. Yeah. Can you tell? I read one Quanta article recently, I thought it was really good, and now I'm recommending Quanta to everyone. Oh, brilliant. Why does my proof do that? Yeah, everyone loves 3 blue, 1 brown. Especially on this live stream, everyone loves 3 blue, 1 brown. International A-levels are treated the same by us as A-levels taken in the UK. We count those as equivalent. 3 blue, 1 brown has got a new podcast out. That's very interesting. I've just listened to the first 2 episodes. Yeah, it's really good. Probability is not on our syllabus. Do we need to know it? Not for the maths. Well, I suppose a tiny bit of probability. If you flip a fair coin, there's a half probability of either head or tails coming up. Is all the probability I know, which is all the probability you might need for a math question. Kind of equal flips or weighted coins. The kind of idea of if a coin is biased so that it's got probability P of coming up heads, then what happens when you flip 2 of them, or what happens when you've got 3 of them and you're thinking about, can I get 2 heads and 1 tail? How likely is that? So sort of different combinations of outcomes. There's a session on this sort of probability entirely related to combinations of things and counting how many combinations there are. So not very complicated probability theory for maths. Basically just counting really. Yeah, let's call it just counting. Right. Does anyone ever get 100? Not very often. It's a hard test. How much did I get for the MAT? I have never done the MAT. How important is it? It's probably the most important thing in terms of shortlisting for who we invite for interview. After that, we've got interviews as well. So we've got 2 different measures of you doing some maths problems. We've got you doing maths problems at interviews, and we've got you doing maths problems on the MAT. So some waiting between there, I suppose. But in terms of getting to the stage of being interviewed, I think maths the most important thing we've got. People are leaving, which is fine. Is maths score important? It is important if you do computer science. You sit the maths test as well. It's also important in being shortlisted for interview. And computer science is very oversubscribed. There are lots of people who want to do computer science, so math is important for shortlisting on that one as well. Specific question. If my school offers further maths, yes, don't take it. Oh no, I'm studying in my own time for reasons. Aha, great. But no official qualifications. Okay. Is that a disadvantage? Well, so let's put it this way. You know the maths, right? If you're learning in your own time, then you know the maths, which is the most important thing. No formal qualifications. A bit of a shame for me and my systems of looking at formal qualifications. But hey, you can tell us in your personal statement, where you can write anything, you can tell us that you're demonstrating independent study skills, you really like maths, you've learnt lots of further maths, you're very excited about it. And I think doing that sort of thing makes you better at all of the maths that you do. So that's probably going to make you better at maths questions by just thinking about maths. Not because the topics come up, because they don't come up. There's no further maths on the mat. The topics don't come up. But having practice of doing extra bits of maths study. That was a very detailed answer to a very specific question. But yeah, you go. You go. Yes. How come there's no applied or stats on the maths? This is a great question. Oh, not complaining. Oh, okay, right. We are not seeing eye to eye here. There's no applied or stats because we're only using the first half of A-level single mathematics, which doesn't have any it doesn't have any applied or stats on. We don't know what order people learn statistics or applied stuff in, whether they know it by the time of math or not. So if you're learning maths and further maths in parallel, then how much mechanics have you seen? Not really sure. I wouldn't mind it if we did some statistics and applied maths. I think that would be fun, but not fair on people who haven't learnt it yet, of course. Right, okay, so we're not going to do it. Do I think step 1 is helpful? Yes. Step 1 used to be a test that had tricky maths questions on. Step 1 uses more maths. It uses all of A-level maths. So if you're looking at step support foundation modules, eventually, one of the problems with step support program in terms of math preparation is that eventually you get onto topics that are not included on maths. So eventually it sort of starts being, you start looking at questions and thinking, oh, I don't know how to do this one. Maybe that's because it's not on something I know yet. Yeah, sorry, people are asking this lots of times. Thanks for doing this live, brilliant, good. How are we doing? We still got chat, I'm still miles behind. I'm going to catch up on chat. How to solve it is great. Personal statement tips, maths and stats. Tell us about how much you like maths and stats. Tell us about how you're preparing for university. What did I get in STEP? I got SS in STEP 2 and 3. Is this all available? It's all available online. The whole thing's available. This is all up. This rambling chat is being uploaded to YouTube somewhere as we speak. Isn't that lovely? You can watch this back afterwards. You don't have to stay live. Okay. How to make the most of past papers? I would try some of them. I would not do them all under times conditions. I would do some of them really quickly or just really slowly, or just whenever, bits and pieces. I would use some of them, like how I'm using some of them here, just tearing them apart and looking at the separate questions. I would do some of them towards the end when we're getting ready to do the test. I'd do some of them under timed conditions, I suppose, but I would try not to look at the answers at all, really, ever. If you're stuck on a question and you can't work out the answer, don't look at the answers. That's why I'm keeping the solutions separate from today's worksheet, right? Don't look at the answers, just keep thinking about it. Have it as something you're stuck on that you come back to, you know. A couple of weeks' time, you come back to it, you find it at the bottom of a stack of paper, like, there's that question again. Oh, it's 3. Can't believe it's the sum of geometric series. Area of a triangle using lengths. Ooh, okay. Yeah, Heron's formula in chat. Brilliant, right, cool. Which college do you work at? I have just finished. I've just finished working at New College. I was at New College for a little bit. I've finished. I reached the end of my contract at New College. Ha ha ha. Sam asks, is there negative marking for multiple choice? Sam, you asked that about 10 minutes ago. Really sorry. There's no negative marking. It's 0 or 4. Probability fans, including Scottish probability fans, you can guess, and if you just guess, then there's a 1 in 5 chance. There's a 1 in 5 chance that you get the right answer and get 4 marks, and there's a 4 out of 5 chance that you get no marks. So your expected number of marks, the kind of average that you expect, is about 0.8 marks for a question, if you just guess. Good, right. Ali spotted the change of colour scheme. We changed colour scheme for the MAT livestream. I just thought it was time to use a different colour. A little bit fresher, brighter colour scheme. I'm not sure. I actually changed it about 10 minutes before we went live. About 10 minutes before we went live, I thought, I want to change all the colours, so I changed all the colours. It's astonishing that any of it works and the live stream hasn't broken. Cool. People want to ask about me, which is fine, I suppose. I work on fluid dynamics, or at least I used to work on fluid dynamics as a branch of applied mathematics. That's not a clue for MAT questions. None of the MAT questions are about fluid dynamics, don't worry. I don't expect anyone to know about the same sorts of maths as me. I like integrals and differential equations, and I like solving things that have some correspondence to the real world. So maybe you have a real world thing, and then you do some differential equations, and that tells you something about the real world. If you don't do computer science A level, would it matter for the MAT? No, that's fine. You do not need computer science A level for the MAT. Good, right, cool. Pretty good MAT score, but do poorly at the interview. That's tricky because we're using the interviews to decide, together with everything else. We do look back at your MAT score, but we're going to look at both. So we might make an offer. We might make an offer instead to someone else who's done okay on MAT and done well at the interview. Again, or maybe not. Who knows? We look at everything together when we make our final offers. So yeah, interview performance, MAT performance, everything else we know. So yeah, never say never. But interviews are just maths questions again. We're just going to ask you more maths questions. Something else vouching for Quanta, my new favourite magazine, reminding me about Medium, which sometimes has good maths articles on there as well. Oxford versus Cambridge, because people have found out that I went to Cambridge, so Oxford versus Cambridge. Big difference, Oxford offers maths and philosophy, maths and statistics, maths and computer science. Those are 3 joint honours courses. You could apply to do one of those, where you do some maths and something else alongside. Joint honours course, not a thing at Cambridge. Also, Oxford has the Andrew Wiles building, which is fantastic. And it's where all the lectures are. When we're having lectures in person, we have all our lectures in the same building. We've got kind of one building that's big enough to have all the maths researchers upstairs and all of the maths lectures downstairs during normal times when we're allowed people in the building. So everyone in one place. Cambridge, a little bit more spread out because there's not enough lecture rooms in their building for all the undergraduates. Personal statement tips for maths and stats. Tell us about maths, tell us about stats, tell us about what you're interested in, tell us about how you're preparing for maths at university. Same advice I give to everyone really. Why are you applying for this course? Why are you going to be good at it? What are you doing to prepare to be good at this course on the when you're here? Sort of same whether you're applying for maths and stats or French. Just what are you doing at the moment? Why are you looking forward to this course? What are you doing to prepare? What are you specialised in? The questions are coming around a little bit again. I'm going to start rejecting questions I've already answered. Haha. I do fluid dynamics. I don't expect you to know about fluid dynamics. For places, MAT more important. Yeah. So MAT versus interview. We're going to look at both. Interview, I suppose, is more recent. You have multiple interviews if you're interviewed by Oxford. So we've got more measurement there. But we do look at your MAT score as well. That is important. I'm going to say that interviews may be slightly more correlated with how we make our final offers, but it's vague. Okay, I'm an applied mathematician. I don't do computer science A level. Okay, right. Computer science question has been answered. Which college am I at now? I don't have a college right now. I have no college. I work in the maths department. My job is to look at all of the colleges and try and make sure that we're being fair across all of the colleges. So no college for me at the moment. Yeah, Ali's in year 11. Don't bother with the timed conditions, says Ali. Cool, good. Ooh. Josh has noticed, yeah, so I changed all the colour schemes and then I realised that it kind of clashes or matches my shirt. So, unintentional and not very aesthetically pleasing. Right, okay. Can we have a question on bubble coalescence on the mat? Your bubble coalescence on the mat. You could do something. It'll be fine. You could do something. Careers primary school teacher. That's fine. Hey, we need teachers, especially primary school teachers. That is basically an academic career, right? That you're doing education and teaching. So I disagree with your question. And also, even if you said I want to do a job that involves no maths at all, I'm really interested for my degree, but for my job I want to be a lawyer, that's fine with me. We're looking for the people who have the most potential to succeed on our course, whether or not you want to be an academic mathematician or not. It's not an entrance requirement to be a research mathematician. Okay, yeah. What about this knowledge? This question on computer science? Yeah, it's kind of just maths. That's the thing about the computer science questions on the MAT. They're sort of just maths. I can do them, and I don't know anything about computers, and I don't know anything about computer science. I can't do them very quickly, and I can't do them very well, but the questions make sense to a mathematician. So they're sort of just mathematics questions, if that makes sense. Maths and physics personal statement plans. Tell us why you want to study this. Tell us how you're preparing for it and why you'd be a good student on the course. I'm getting better at that. Terrible predicted grades. So terrible predicted grades is quite bad because that's your teachers or your UCAS reference telling us that they don't think you're going to make the standard for the prerequisite knowledge, the kind of maths that we reckon you should know before you start Oxford. That's quite a bad sign because your teachers or your UCAS reference, they're supposed to know you quite well to predict how well you're going to do at the end of the year. We know they're not always correct. So we know that predicted grades are not always perfect. And if you have bad predicted grades, but somehow you do really well in the maths, that is interesting. I'm not going to lie, that is interesting that you've done well in an actual maths test. Predicted grades, kind of words and predictions, actually doing a maths test, that is more interesting to us. We would have some questions though, we would want to know. Some people's schools refuse to predict them A star sometimes, which is a little bit odd, but sometimes it's not fair. And in that case, you can very easily be in this situation where your school did something unfair, and now you're not predicted A star, but you're amazing at mathematics and you'd be a really good student. If we get that sense that you'd be an amazing student, really good at mathematics, then in some sense it doesn't matter what it doesn't. Let's not do that. It doesn't matter what you do through the admissions. It doesn't matter what you do through the admissions process. I was going to say, but it sort of does. Sorry. Right. Revision plan for MAT. There's a very short syllabus of MAT questions. We're going to go through it quite slowly over the next 10 weeks. Every live stream is going to look at a different bit of MAT syllabus over the next 8 weeks, looking at different bits of the MAT syllabus. If you want to look ahead and look at the other bits, I'm talking about this section at the start of each worksheet where it says MAT syllabus, just this bit. If you want to get ahead, you could just look at those and decide whether you know that bit or not, and read the revision notes. That might be a good way to get started with your MAT preparation plan. Otherwise, this series of MAT live streams is supposed to be a MAT preparation plan. If I'm just applying for maths, is it best to talk about maths? Can I talk about links to computer science and physics? You can talk about links if you want to. You can say I'm applying for maths. I'm interested in doing maths at university because I want to understand how the universe works through quantum physics or something, and I've decided that understanding maths is the best way to do that. You can tell us that sort of thing. That's fine. You're allowed to be interested in other stuff. I'm interested in physics. Right, cool. How does the actual course differ from maths at Oxford in terms of what the students actually study? Not very much. There are lots of options at both Oxford and Cambridge in the third year, for example. So by the time you get to third year, lots of options in both, which means that you can, within Oxford, you could be doing quite different maths degrees to somebody else from Oxford, and within Cambridge, two students could be doing quite different courses, so that you could have variety within each university. It doesn't really make sense to say which one is the difference between the two universities, because there's a difference within as well. Are we going to get a MAT book on Amazon? Yeah, so hopefully there's going to be some sort of, if the worksheets turn into a free book, then you heard it here first, that Stephen Sickloss's free steps book is a really great thing. If we had a version of something like that for MAT, then it's probably going to be based on these questions, to be honest. Right, cool. Josh is off. Bye, Josh. James, can I email you? There is an email address in the YouTube description that has more specific questions. It's hard to comment on fee status in advance, but you're welcome to email the email address in the YouTube description. Good. Maths club. So if somebody says they missed math circle, which I think they mean maths club, Maths Circle, Maths Club stuff. It's all still online. You can watch all of it back. It's not live anymore, but you can see the episodes. And yeah, you can talk about YouTube videos in your personal statement. This is the longest chit chat we've ever done. Yeah, we're trying out a new thing. People watching the video back, I'm going to have to really strongly advise them to stop at the 1 hour mark. Right, okay. Honest opinion, mathematics only at Oxford or Cambridge. I don't know. So when I applied for Cambridge. I sort of think these days Oxford's got a new building. I didn't do a huge amount of research when I was applying into whether I wanted to apply to Oxford or Cambridge. I didn't really look into joint honours courses or other things like that. It's questions about just maths. I would look really closely at both courses at the moment. And I think if I were you, I would think about maths and STEP as well. Cambridge is using this big exam called STEP. Oxford's using a sort of smaller exam earlier on in the process. You might decide that one of those sounds like more your style than the other one. Okay, I've caught up with chat, which means I think I'm going to wrap up the live stream here. There's an email address in the YouTube description if you want to get in touch otherwise. I've enjoyed this chit chat bit at the end. I think next week I'm going to try and get through more math questions during the first hour. But yeah, it's been nice to catch up with people after a couple of weeks break from Maths Club stuff. Good, yes. And you can't apply for both because it's loads of admin work for both Oxford and Cambridge to do all of these maths tests and interviews. I think that's the reason you can't apply for both. My favourite number is huge. It's the one from the doubled arrangements episode of. So the Maths Club episode, Everything Wrong, has got a huge number in. That's currently my favourite number. Right, okay, bye. Okay. If you've seen anything I've done before, you know that I'm terrible at ending live streams. So I'm going to try and work out which buttons to press. I think this one.